The way we think about causation in an epidemiologic perspective is we try to ask the question, what would have happened had things been different? What would have happened had everything under the situation been exactly the same, but the only difference is the exposure hadn't occurred? And we call that the counterfactual model, right? We think about what would have happened counter to fact, counter to what actually happened, and would things have been different? What we measure in epidemiology are associations. We measure a comparison of rates of disease in two populations, and we see whether or not those rates of disease are associated with some particular exposure. What we want to measure are effects, and effects are when we measure the same population under two different scenarios. We measure them, their rate of disease under exposure and their rate of disease under non-exposure. And that second scenario, where the effect measure, we can't actually ever observe because we can never truly observe people under two scenarios. So we have this problem where the thing that we want to measure, the effect, isn't actually measurable. So what we want to do in epidemiology to get at effects is get our associations that we measure as close to the effect measure as we possibly can. And we do that by thinking about the counterfactual model and how we can approximate that two scenarios in which we have the same people under observation twice, which we can't really have. And essentially there are two solutions to that problem. So the first is to assume that everything would be the same if I had just changed the exposure. So the example of that would be if I walk into a room and I flip the light switch and the light doesn't go on. And so I check it, and 9 times out of 10, probably even more than that, if I change the bulb, it works. So that works really well in cases where we understand the system very well, and the light turning on is a very simple system. In epidemiology, we're dealing with human beings who are very complicated systems. And so we can't really make the assumptions when we're studying the relationship between, say, some environmental exposure and some cancer. We can't really make the assumptions that if I had just changed one thing, I can explain everything else and I know everything else that would have happened. So what we do in epidemiology is we have a comparison group. We have some other population that didn't get the exposure that I'm interested in, and we compare them to the population that did get the exposure. And how well we do at getting at causation depends on how well that comparison group can stand in for that, what would have happened to the exposed group had they been unexposed. And we never know for sure how well we've done at that, but we want to think about all the ways that that can go wrong, and we want to think about different ways that we can go about addressing that. So in epidemiology, we think a lot about randomized trials, and randomized trials are really nice for getting at causal effects, because if I randomize two groups of people, two populations of people, some to get the exposure and some not to get the exposure, well, the law of large numbers says that if I randomize a large number of people, half to get the exposure and half not to get the exposure, then on average, those two populations should be very similar. And it's reasonable in that case to think that the unexposed group can stand in for what would have happened to the exposed group had they been unexposed. And in that case, I can reasonably assume that I'm going to get close to the causal effect, even though I'm measuring associations. When I don't have control over the situation, when I move into the world of observational studies, like the case that you're talking about here, I don't have control over assigning the exposure. I then have to think about all the ways in which the people who got the exposure might be different from the people who didn't get the exposure. We talk about that as epidemiologic confounding, and we think about ways that we can control that analytically by collecting information on the population, all those factors that might differ, and doing statistical adjustment to try and make those populations as similar as we can, or we can try to match the populations on those characteristics to try and make them as similar as we can. But the goal is always to try and find a way to get those populations as similar as possible, so that the only difference really within those populations is the exposure, such that I'm reasonably confident that the unexposed group can really do that job of standing in for the counterfactual for what would have happened to the exposed group had they been unexposed. And that's typically how we think about causation in epidemiologic research. We think, how close did we get to that counterfactual before we want to make assumptions that we're looking at causation.